System requirements. Functionality. The Instrumented Protective System, IPS, should normally be energized except for lamp outputs. A 1 logic signal is the normal state, and a 0 logic signal indicates an abnormal, trip or failure state. Output signals should revert to a 0, de-energized state on power failure or component failure. For commissioning purposes, it should be possible to force I/O signals to certain states via the engineering workstation. This forcing feature should be under key lock, and forcing should be ineffective when the key is removed. Loss of data communication with the Digital Control System, DCS, or in the Sequence of Events Recorder, SER, and Maintenance and Engineering Network should not result in trips or status changes of the IPS communication points. Communication recovery should be automatic. The supplier should indicate the type of output, hardwired, that can be made available to permit backup, annunciation of communication failure at the DCS operator workstation. The operator should be continuously informed of the system status through IPS system and utility alarms transmitted to the DCS. These alarms are supplier-specific and should be included in the scope. At a minimum, a common cabinet utility alarm and a common system alarm should be transmitted to the DCS for the operator's attention. For IPS system and utility alarms, additional diagnostic information may be transmitted from the IPS to the DCS as indicated in the requisition. A hardwired alarm should be provided for total IPS failure. The supplier should provide a list of parameters that may cause a trip if not properly set. Certification. Where TÜV approved or TÜV certified is specified, this should be in accordance with relevant standards. The required class should be indicated in the requisition. IPS hardware and system software, if applicable, should be certified by TÜV. All input and output cards should be TÜV approved. All input and output cards should be fail-safe, except for those outputs driving non-safety related outputs and alarm lamps, as indicated in the requisition. All conditions regarding the application of the IPS listed in the TÜV approval report and IPS safety manual should be met. Any disagreements between this document and the constraints of the TÜV approval report should be indicated in the quotation. TÜV certification should include serial communication with the DCS, SER, and Maintenance and Engineering Network and IPS to IPS communication. The IPS should be unresponsive to faults in the DCS, SER, and Maintenance and Engineering workstation. Response time. The cycle time of the IPS should be a maximum of 300 milliseconds, resulting in a time from input change to output response of less than 600 milliseconds, with all spare capacity occupied. For fire and gas systems, the maximum cycle time should be 500 milliseconds. The supplier should indicate in the quotation the system base load overhead and the I/O load in terms of response time. Quality. The hardware and software products quoted should have a proven field record. The supplier should include a reference list in the quotation giving technical order size, year, hardware, and software revision levels. The supplier should specify which burn-in and heat cycle tests will be performed. Revealed failure robustness. CPUs, if used in an IPS, should be revealed failure robust. Revealed failure robust internal communication buses and IPS to IPS communication links should be used. If the application logic is performed by solid state, magnetic core or relay cards, these cards are not required to be revealed failure robust. The IPS DCS communication and the SER and Maintenance and Engineering networks should be revealed failure robust. Unless otherwise indicated in the requisition, revealed failure robust analog and digital input cards should be used for those inputs performing executive actions. Unless otherwise indicated in the requisition, digital output cards should be revealed failure robust, except for those outputs driving alarm lamps. If a revealed failure robust component fails, the other S should continue to operate in crippled mode. In this mode, a time limit of up to 72 hours, actual time limit depends on the application and should be stated in the requisition, should be defined to allow for sufficient repair time of the faulty component. Without corrective action, and after this period, the outputs concerned should de-energize. The time outstanding should be transmitted to the DCS for operator information. In the event of a failure of a revealed failure robust component, power supply, or other function, The system should change over to crippled mode operation without causing spurious trips and should indicate the fault type and location. The supplier should specify if there are cases where replacement of a component can lead to a complete IPS stop, de-energizing of outputs, or any loss of functionality, e.g., detection of trip conditions. Responsibilities. The supplier is responsible for selecting components to perform the functions described in the functional logic diagrams, narratives, or other documents. The supplier is responsible for the layout of the cards in the racks according to the requirements given in this document. Structure. The requisition should indicate a suggested number of independent IPSs. This number should be based on the relation, operation, and maintenance of the various process units. The supplier should verify the resulting IPS loading and cycle time and propose a different arrangement of IPSs where required to comply with loading criteria. Each process unit may contain more than one separate IPF group. In general, one I/O card should not contain the I/O of more than one process unit. Non-FGS-related LAMP outputs may be combined, i.e., no process unit split is necessary. Cards belonging to one group should be grouped together. Any exceptions to these rules should be stated in the requisition. Each IPS should operate independently of other IPSs, except for the communication links. Signals for IPFs of Class 3 and higher, and Class 2 if implemented in the IPS, should be communicated through the IPS to IPS communication link. The communication route via the DCS or via the SER and maintenance and engineering network should not be used for this purpose. The suggested system overview should be indicated by the principal in the requisition. Spare capacity. The minimum hardware spare capacity per process unit in terms of unused I/O channels and power supply should be indicated in the requisition. These spare I/O channels should be fully wired to ELCO sockets interconnection boards. The hardware spare capacity, in terms of spare I/O card positions over and above the installed spare capacity, should be indicated in the requisition. The requisition should also indicate whether or not these spare card positions should be wired to ELCO sockets. The application software spare capacity for the IPS PLC, if applicable, for the SER-PC, and for communication links should be 15% at plant startup. The cycle time calculations should be based on the assumption that all spare capacity is used. The supplier should propose the minimum required number of different card types. If major cost reductions are possible by introducing more card types, the supplier should provide options to achieve a balance between the minimum number of card types and system cost. System hardware. General. Input and output cards should have electrical isolation between field equipment and the IPS. Unrevealed or revealed failure robust inputs should be wired to separate revealed failure robust sets of input cards. It should be possible to replace cards without switching off the power and without disturbing the process. Short-circuiting of individual inputs and outputs should not affect other inputs and outputs, respectively. The use of fuses for the protection of individual inputs and outputs should be avoided. To assess the supplier's recommendation for spare parts, theoretical failure rate figures of all boards, power supply units, and other functional subassemblies in the system should be given in the quotation. Calculations should be based on the worst case and the normal environmental conditions specified. The supplier should indicate whether anti-static precautions are necessary when handling cards. If such precautions are required, grounding wrist straps should be supplied as permanently installed items. Analog inputs. The IPS should be able to receive the following types of input signals: 420 mA non-earthed passive 24-volt DC 2-wire, 420 mA non-earthed active 24-volt DC 2-wire, 3 or 4-wire platinum resistance temperature detector RTD, pulse frequency type K, J, or B thermocouples. The requisition should indicate to which signals square root extraction is applicable. Analog inputs should have open and short circuit and out-of-range detection. The range should be configurable per input channel. The detected results should be available for use in the application logic. Therefore, transmitters, including those used for high-trip functions, should be direct-acting. The power for field-mounted passive 4 to 20 milliamp transmitters connected to the IPS should be supplied by the IPS. Digital inputs. The IPS should provide the wetting voltage for digital inputs which are connected to switches with voltage-free contacts, e.g. reset and emergency shutdown switches. For solid-state sensors, e.g. proximity sensors, voltage-carrying inputs should be provided. Normally open digital inputs should be provided with open and short circuit detection per input channel. The detection results should be available for use in the application logic. Normally open digital inputs for field-mounted reset switches, MOS enable switches, lamp test, acknowledge, and reset switches in local panels do not require open and short circuit detection. IPS PLCs, in addition to their normal connection to fail-safe input cards, should allow trip functions to be connected, hardwired, to either the watchdog or a secondary power disconnection device of the output card on which the action has to take place. This function should not be provided by application software. Applicable tag numbers should be indicated in the requisition. Digital outputs. The IPS should provide the power for the output circuit loads. The following output types should be supported. Solenoid valves with coil voltage of 24 volt DC. The power consumption should be indicated in the requisition. Interfacing relays to motor control units with coil voltage of 24 volt DC and power consumption of 3 doublets. Control room and/or local panel alarm lights with lamp rating of 24 volt DC and power consumption of 3 doublets. Normally de-energized outputs, except for lamp outputs, should be provided with open and short circuit and earth fault detection per output channel. The detection results should be available for use in the application logic. The detection should be independent of cable length between output card and final element. IPS PLC outputs should not be switched via relay contacts. Only solid-state switching should be used. System and application software. Only the supplier's standard configuration method, e.g. FLD, RLL, or SFC, should be used. Neither mnemonic nor high-level language-type programming, such as Pascal or BASIC, should be used. For PLC-type IPSs, the setting of trip alarm levels for analog inputs, setting of timers, and selection of normally open or normally closed configuration for digital I/O should be done by software configuration. For other types of IPSs, this should be explained by the supplier in the quotation. The supplier should indicate the facilities and limitations of the system, if any, in performing simple calculations such as compressor surge trip parameters, furnace air-fuel ratio, etc. The supplier should indicate whether the combination of inputs into a calculation may be such that a calculation error can occur, e.g. division by 0. In that case, the supplier should propose the logic changes required to avoid the possible error and request the required actions to be incorporated in the logic in case the input combination is such that a calculation error would occur, e.g. trip the unit or hold the last inputs and alarm the operator. DCS interface points should be configurable. Neither mnemonic nor high-level language type programming should be used. Application programs, if applicable, should be split into well-defined functional modules. The application programs, software, if applicable, may initially be stored in RAM for system testing, commissioning, and plant startup, and should thereafter be stored either in non-volatile EEPROM or in volatile RAM or flash EEPROM, as indicated in the requisition. For IPS PLCs, the supplier should indicate in the quotation whether decompile software is supplied with the system. Both the operating system compile software and, if applicable, the decompile software should be 2V approved. For IPS PLCs, a software package should be supplied which is capable of comparing two application software versions and indicating where the variations have taken place. This package should be 2V approved. 2 sets of operating system diskettes should be supplied. The operating system diskettes should allow at least 5 installations of the operating system on different PCs for each set of diskettes. If there are limitations with regard to the number of installations, uninstall utilities should be provided. Communication IPS, DCS. Each IPS should communicate via individual galvanically isolated serial links with the DCS using Modbus Remote Transmission Unit, RTU, protocol. Changing the memory allocation to suit the particular application should be user-friendly. The serial link communications as indicated in the I/O list should be based on the following principles. For each hardwired analog input, analog measurement to DCS, the supplier should indicate units and resolution. Trip setting to DCS, trip alarm to DCS, measurement diagnostic status to DCS, maintenance override from DCS, feedback on maintenance override to DCS, first up indication to DCS. If not required, it should be indicated in the requisition. Input force status to DCS. For each hardwired digital trip input, trip alarm to DCS, input diagnostic status for inputs with short circuit or line monitoring to DCS, maintenance override from DCS, feedback on maintenance override to DCS, first up indication to DCS, input force status to DCS. For fire and gas inputs, details depend on the detectors used and should be indicated in the requisition. For each hardwired acknowledge and first up reset and lamp test input, no signal to DCS required. For each first up reset generated by the DCS, the first up reset signal from DCS. For each hardwired operational override input, the operational override to DCS. For each reset and permission input generated by the DCS, the relevant signal from DCS. For each hardwired reset and enable input, the reset enable signal to DCS. For each IPS output, the output state to DCS, the output diagnostic status for outputs with line monitoring to DCS, the output force status to DCS. IPS system and utility alarms, see previous functionality requirements. IPS and DCS suppliers should work out the message contents and other details such as hardware and software requirements. The DCS system is the communication master. The DCS supplier has the final responsibility. The supplier should indicate in the quotation whether full floating point communication between the IPS and DCS is possible. If generated in an IPS, all signals should be available for transmission to the DCS within 1 second. The supplier should indicate the refresh rate of the analog signals available for transmission to the DCS. The supply and testing of all interconnecting cabling should be the responsibility of the IPS supplier or the DCS supplier, as indicated in the requisition. Alarm signal handling. The IPS should have facilities to generate alarm output signals, serial and hardwired. Each alarm is included in a group, except for the system and utility alarms. Each group should form a first failure alarm group in which the first trip alarm that comes up is recognizable. For local panels, all alarms should be assigned to 2 first up groups, one for the local panel itself and the other for the signals to the DCS. The first failure resets for these 2 groups should be by means of a button on the local panel and a signal from the DCS, respectively. The first failure alarm coming up in a group should be transmitted as such to the DCS, or in the case of local panels, should cause the lamp to flash at twice the frequency of subsequent alarms. Groups tagged MISC, miscellaneous, do not require the first failure feature. For alarms presented to the DCS should take care of the sequence upon receipt of the alarm and the first failure indication. First failure reset signals should be provided by the DCS. For local panels and FGS mimic panels, the alarm sequence should be in accordance with ISA S18.1M, alarm only with lock-in facilities, and ISA S18.1F, first failure or first up alarm groups. First up reset and lamp test should be hardwired potential-free contact inputs from the local panel or FGS mimic panel. The supply voltage and power consumption of the audible alarms on the local panels and on the FGS mimic panel should be indicated in the requisition. The acknowledge, first up reset, lamp test, and audible alarms per group need not be reflected on the functional logic diagrams provided. DCS-generated pre-alarms indicated on local panels should be wired direct from the DCS to the lamps on the local panels. These alarms should not be incorporated in a test and acknowledge group, and therefore the lamp test should be functionally built into the DCS, i.e., power all lamp outputs when the lamp test on the DCS is activated, and the lamps need not flash when an alarm is activated. IPS common utility and common system alarms should cover such conditions as partial power supply failures, abnormal temperature conditions within cabinets, CPU failure, module failures, and earth faults. These alarms should be logged by the SER. For each IPS cabinet, at least 1 common utility alarm and 1 common system alarm should be transmitted to the DCS. Sequence of events recorder. Preferably, all CR-related information should be transmitted with a timestamp to the DCS through a standard protocol, and all functionality should be included in the DCS. The DCS should also have the possibility to combine SER information from various subsystems with the DCS alarm list and audit trail so that a complete sequence of events can be presented to the operator. Detailed SER requirements are given due to the non-availability of this functionality from the supported DCS suppliers as standard. An SER system should primarily function as a backup for the DCS logging equipment and provide a high-resolution audit trail. For postmortem analysis, the SER should be capable of storing 100,000 timestamped events in a circular file. The timestamp should equal the IPS clock time at the time the trip alarm is generated, with a resolution equal to or better than the smallest scan time of any of the IPSs. To allow for SER or communications failure, at least the last 100 events should be stored in a buffer in the IPS. The following signals or changes of state should be logged by the SER. For each hardwired analog trip input, trip alarm, measurement diagnostic status, e.g. out of range, maintenance override, feedback on maintenance override, input force status. For each hardwired digital trip input, trip alarm, input status, e.g. line break, maintenance override, feedback on maintenance override, input force status. For fire and gas inputs, details depend on the detectors used, refer to requisition. For each hardwired acknowledge and first up reset and lamp test input, the acknowledge first up reset / lamp test. For each first up reset input generated by the DCS, the first up reset signal. For each hardwired operational override input, the operational override. For each reset and permission input generated by the DCS, the relevant signal. For each hardwired reset and enable input, the relevant signal. IPS system and utility alarms. Each individual system and utility alarm. Time synchronization of all IPS's SER and DCS should be effected from an external clock. The supplier should state how this will be achieved. For each SER input, a unique tag number and service description should be assigned. A tag number should consist of at least 12 alphanumeric characters, starting with either an alpha or a numeric character. The minimum number of characters for the service description should be 30. The supplier should clearly confirm the maximum system capacity for accepting tag numbers and should identify any constraints. It should be possible to copy the SER file onto a backup medium. The location of the SER should be indicated in the requisition. The supplier should provide all software for the SER and its configuration. It should be possible, with the correct authorization by means of a password or key, to disable and enable inputs from being recorded on an individual, selected group, or process unit basis. The following reporting functions should be provided, and their display activated on request only. Daily reports, 24 hours. Shift reports, 8-12 hours. Maintenance and operational overrides usage, process alarms per process unit. System utility alarms, forced I/O. Event playback and printout for selected timeframes, process units, and tag numbers should be possible. The supplier should state the details in the quotation. Common database facilities such as sorting, querying, etc. should be available, as well as the possibility to export the SER file to Microsoft Windows-based applications. The supplier should state the possibilities in the quotation. Historical data should be retained on loss of power supply to the system. Engineering interface. The engineering interface should be such that group modules can easily be displayed. It should be possible to view the status of input and output signals and the actual values of inputs in engineering units. It should be possible to view the status of intermediate points in the logic. Access should be password protected or under key lock. Project timing. The supplier should specify the system hardware freeze date and the software freeze date to meet the required site delivery date indicated in the requisition. Hardware construction requirement. Cabinets. The type of cabinets should be the supplier's standard unless otherwise specified in the requisition. The cabinets should be painted and finished to the supplier's standards and suitable for indoor use. All cabinets supplied should be identical and have the same physical dimensions. If specific cabinets are specified, their physical dimensions should be provided in the requisition. The cabinets should be of the freestanding type, with two power supply facilities. The required power supplies should be provided by the principal. The required voltages and the maximum power consumption of the IPS, DCS, and SER should be stated in the requisition. All necessary internal power supplies, including uninterrupted power supplies, UPS, for the IPS system, should be provided by the supplier. Power consumption and the acceptable tolerances for voltage and frequency should be clearly stated for each type of power supply. The power supplies should be designed to cope with the tolerances specified for voltage and frequency fluctuations, harmonics, and transients. The UPS system should ensure that the IPS remains operational during power interruptions, including momentary outages and brownouts. The system should be able to ride through a minimum of 20 milliseconds power interruption without requiring a reset. Power distribution. Power distribution within the cabinets should be clearly defined. Power supply units and distribution boards should be easily accessible. Power supplies should be provided with adequate filtering to prevent electrical noise from affecting the system's operation. The design of the power distribution should minimize the impact of electrical interference and ensure that safety and operational integrity are maintained. Batteries. Batteries used for backup power should be of the sealed maintenance-free type unless otherwise specified in the requisition. The battery capacity should be sufficient to support the system for a minimum of 1 hour under normal operating conditions. Battery chargers should be provided and should be designed to maintain the batteries in a fully charged state without causing damage. The supplier should provide details of the battery type, capacity, and expected life in the quotation. Alarms should be provided to indicate battery low voltage, battery charger failure, and battery disconnection. These alarms should be included in the common utility alarm. Environmental conditions. The IPS should be suitable for operation under the specified environmental conditions. These conditions should be detailed in the requisition. The environmental conditions should include, but not be limited to, temperature range, humidity, vibration, and EMC, electromagnetic compatibility requirements. The system should be designed to operate reliably in the specified environmental conditions without degradation of performance or safety. Cabinets and equipment should be protected against dust, moisture, and other environmental contaminants. Where necessary, cabinets should be fitted with heaters, fans, or other climate control equipment to maintain the internal environment within acceptable limits. The supplier should state any additional environmental requirements or limitations in the quotation. Factory Acceptance Test, General. The Factory Acceptance Test, FAT, should be conducted at the supplier's premises unless otherwise specified. The FAT should demonstrate that the IPS meets all functional and performance requirements specified in the requisition. The FAT procedures should be agreed upon by the principal and the supplier before the test. FAT Phase 1. Phase 1 of the FAT should include a visual inspection of the hardware and a review of the documentation to ensure compliance with the specifications. All wiring, labeling, and physical construction should be checked for correctness and quality. The power supply and grounding arrangements should be verified. The system should be powered up, and initial checks should be performed to ensure that all components are operational. FAT Phase 2. Phase 2 of the FAT should include functional testing of the IPS. All input and output signals should be simulated to verify the correct operation of the system. The system response to simulated faults and abnormal conditions should be tested. The communication interfaces with the DCS and other systems should be tested to ensure correct operation. The sequence of events recorder should be tested to verify that it accurately logs all events with the correct timestamps. The system software should be loaded and configured as specified, and all functions should be tested to ensure they operate correctly. Any discrepancies or issues identified during the FAT should be documented and resolved before shipment.